let us use question 1 to practice theorem 1 to theorem 3. Now our question says to us that in the diagram below, AB intersects CD at point O and BOD, angle BOD is equals to 30 degrees. AC is produced to E such that angle ECO is equals to 60 degrees and angle ACO is equals to 120 degrees. Now let us fix the language here, because we discussed in our lessons what these symbols mean and how to interpret our diagrams. So let's put this information together so that it makes sense to us. We are saying here that line AB, remember when we write two letters, it means a line. So that means we are told that this is a line. So from here to here is a line. Line AB, we say this line AB actually intersects, it cuts. To intersect means to cut. It cuts line CD. So that means we are told that CD as well is a line. And they cut at a point O. You see here we have one letter. That means this is a point O. And when this happens, we then now have angle BOD. In other words, we're going to form a vertex here, and a vertex, we said it forms an angle. So that means here we're going to form an angle of 30 degrees because there's a vertex. We also then say that we have a line AC which is produced to E. And we discussed this to say when we say a line is produced, it means we are extending that line. So we start first having a line AC, then we extend it to E, we produce it to E. The word produced simply means extend. We have extended the line AC to E. But when we do that, the word such that means that after doing that, we then form angle ECO. In other words, we form the vertex here that will give us an angle here, which we say it is 60 degrees. And we also form an angle ACO. That means we create another vertex here which will measure an angle there, and that angle happens to be measured to be 120 degrees. Now, I believe we have plenty of information to really go and be able to answer our questions. It is very, very, very important to be able to read these questions of Euclidean geometry in this way. Now, under question 1.1.1, we are requested to calculate angle BOC. In other words, to find this angle here. Now, we know that CD actually is a line, is a straight line. We are told here, when we write the two letters CD is a line. So we are told that this is a straight line. And what I see here on this straight line, I actually see two angles, this angle and this angle, that are next to each other. In other words, that are adjacent to each other. That means I can use the theorem that says angles on a straight line are supplementary. So to that end, I will say here that angle BOD, so BOD is what I'm given here. If I add this angle to angle BOC, so the BOC is the one that we have to actually calculate, BOC. If I add these two angles, this one and this one, they actually should be equal to 180 degrees. And as usual, I then have to write my reason here. Why am I saying that? Well, because I know that angles on a straight line are supplementary. Remember that this is the short version of that theorem, to say angles on a straight line are supplementary. From here, this question becomes very, very, very boring, because it is a substitution problem where we know that we were told that Angle BOD is 30 degrees, and we are actually looking for angle BOC, which is going to be that 180 degrees. And really, when you simplify this, we will end up having angle BOC to be equal to 150 degrees, because remember, I'm going to take the 30 to this side, and this means I'm going to have 180 minus 30. I mean, this should give you 150 degrees. Do you think that you can solve this problem using a different method? Please share that method with me and everyone in the comments. Question 1.2 then says to us that prove that ACE, meaning this line here, ACE is a straight line. Now, to prove that this is a straight line, what we can do here is that we can actually use the converse of the theorem that says if the adjacent angles, meaning this angle and this angle, they add 280 degrees, therefore this line must be a straight line. So that simply means that I'm going to add these two angles. I'm simply going to add the angle ECO to the angle ACO, right? I'm going to add those two and see what I get. So I am on question 1.2, and I'm saying I'm adding angle ECO to angle ACO, and what that gives me is that we know that ECO is this one, is 60 degrees, the one at the top, and ACO is actually 120 degrees. And if you add 60 and 120, you should get 180 degrees. So what we are saying here is that if I add these two angles that are next to each other, they are actually supplementary. They become 180 degrees. That means I can then conclude to say, therefore, ACE is indeed a straight line. Is indeed a straight line. And I then have to give a reason to say, why am I saying it's a straight line? Well, because the adjacent angles are supplementary. The adjacent angles are supplementary. The angles that are next to each other on this line, they actually give me 180 degrees. And that tells me that this line must be perfectly straight. They're not greater than 180. They're not less than. Remember that if these angles were greater than, I will have this line going like that, because I'll have an additional angle here that makes them to be bigger than 180. If they were less than, I would have a line that maybe becomes like that, because when you add the two, it has to then be less than 180. So the fact that they give me 180, it means this line will be a perfect straight line. Now when we move to question 1.3, we are requested to write down the sizes of the following angles. So we need to calculate angles here. So we are doing question 1.3 and we are looking at 1.3.1. Now in 1.3.1, we are required to calculate the angle AOC. So this angle here. If you look at this angle, you can see that it's a vertically opposite angle to BOD. So I can simply say that. I can say angle AOC is exactly equals to angle BOD. And we know that that angle is 30 degrees. That means, this angle is also 30 degrees. But what is my reason? The reason here would be vertically opposite angles are equal. Vertically opposite angles are equal because these two angles are vertically opposite. Now one thing that also we can do is that we can start writing in the information that we calculate. We also calculated this to be 150 there. Just to put in that information, it helps when we have to answer further questions. Now 1.3.2, we need to calculate angle AOD. So we have to find this angle. There's a vertex there, so we have to find that angle. For me, I see point O here to actually be a revolution. In other words, I have angles that start from this angle and come back to that angle. There are angles that are adjacent around a point. So that tells me that I can use the theorem that says adjacent angles in a revolution are conjugate. They are equal to 360 degrees. So here I'm going to say 3.2. And what I'm going to do is that I will say here that I have angle AOD, which is the one that I have to get, AOD. Then I'm adding to that angle AOC. So we are adding to this angle here, AOC. We are also adding to this angle BOC. We are adding to it BOC. We are also adding to it AOD. No, we are adding to it BOD. We are adding to it BOD. So we're adding here BOD. And all these four angles must be equals to 360 degrees. They must be conjugate. The reason would be that angles in a revolution, right? These are angles in a revolution. That is my reason. Now, from here, I'm going to substitute to say I have angle AOD, and this one here is a 30 degrees. We just calculated that from the previous question. And this one we said is 150 degrees, is this angle here. And this one is also 30 degrees. We were told in the question, is this angle there. And all this should be equals to 360 degrees. Now, I'm going to have AOD. When I say 30 plus 150, I get 180. Then if you add 30 on 180, we get 210. So this will be 210 is equals to 360 degrees. Now this would mean that angle AOD would be equal to, we are going to take this so that it comes this side, and that means we're going to have negative 210 degrees here. Now if you say 360 minus 210, that should definitely give you 150 degrees. Then that's how you calculate angle AOD. Please share with me in the comment section if you have another way in which you can calculate this angle, or you see another way in which this angle can be calculated. It will be fun to see other ways in which you guys are able to calculate these angles.